Okay, so let's start for today. So last two times we took a look at MPS in general, what you can do with it, how some of the aspects, how to define a language work in MPS, how they look like, and gave a general overview about MPS, not very detailed in most of the aspects, but covering all of the necessary parts that MPS has in general to define a language. And today we are really going to start to build something. So the last times I had some dummy code that I used to demonstrate things, but it wasn't really a consistent language that we used to build. And today we are going to change that. So we are going to start to build something, and then over time add more and more features to it. For today we will first take a look at what the language might look like. Behind me you might already see some little sketch about how a concrete syntax could look like. All the code of this will be on GitHub once we start really working with it. So it will be under my GitHub repository under the URL that you can see in the chat. Right now the repository is empty, so we will really start at with an empty repository, create our project today, and create the first concepts in it, and see how far we get with that today. Tomorrow there will be the next part where we take a closer look at editors, which we will define some today, but they will be really basic. They won't be nice to use. Yeah. So let's take a look at the sketch language behind me here. So this is what I wrote down, I think 1 or 2 days ago, just on a whiteboard, and then photographed it and put it here so that we can take a look at it. So it's a quite rough sketch of some kind of concrete syntax, how our language could look like. So as I said earlier, we are going to build something that to some degree will look familiar to everyone who has already programmed in programming languages that are from a C-like style, Java, C++, or similar. So if we take a look at how the language should look like, we can see that there's like everything that we write is contained in this kind of workbook thing. I named it workbook here. Could also be worksheet or whatever you might think of. So the idea is this is the container. It has a name here. In this case, it's my worksheet. And then there's a bunch of stuff in there. And this stuff in programming languages, we usually call these statements. So it's a list of statements, which in this case can be of different kinds. So what we can see here is like this variable declarations. There's also empty lines here, which is also important because since MPS is a projectional editor, we also need to add this to our language. So we don't get empty lines for free, so to say, like you get in a text editor. It's not much work, but we have to do something about it to make it possible to add empty lines to a program. Then down here we have something like a print statement. So it's used to print something to whatever the console, the screen. We will decide later what it's actually doing. But it's a different kind of statement than the variable declaration up here. And it takes the value to print here in this case. What we can also see is that variable declarations here have a name and an initializer. So they get a value when you create them. Down here we can also see that we can reference variables. So this A here is actually a reference to this variable. And that we will have expressions. So apart from the statement, we will have expressions. If you have programmed in whatever language you have encountered expressions, plus, minus, division, multiplication, but also things like comparison, this is all expressions. So we will create our own small expression language to allow the user to write these things. What else do we see here? We also have, apart from these numbers here, we can also write string literals. And variables can have an optional type here. So all the variables that you see up here, they have no type or whatever associated with them. So they can optionally have a type, which will be more interesting in the later episodes where we take a look at the type system and how to ensure that these types of the variables match and that the initializers are valid for the type that we have defined here, but it's also something we need to keep in mind when actually building the concepts for our language. Yeah, so on a very, very basic level, this is how it should look like in the end. We will start building these concepts now one by one. Yeah. So let's get started. I have already an MPS started up here. So this is MPS 2018 2.5, just the latest version at the moment. As we do this, there is a 2018.3 release pretty soonish. I don't know the exact date, but we are already, I think, at beta 2, so it's expected to be soon. Okay, so the first thing we do is we want to create a new project. So let's select new project from the dialog here. And then MPS asks us what kind of project we would like to create. Essentially, there are three choices here. The first one is a language project, which is used to define a language. Then there's a solution project, which you create when you want to use existing languages but not define new one. But actually, you can mix and match as you like. So in a language project, you can also create solutions, and in a solution project, you can create languages. It's more about what the wizard asks you for and what it's initially creating in the project. So no matter what you choose here, you still have the possibility to add either languages or solutions to the project. And then there's empty project, which, as the name says, creates an empty project with no content in there. But what we would like to do is we would like to create a language project. We can also name it, but let me first select the location so that we don't mix that up. I have already cloned the empty repository to my machine here, so this. And I would also just call so I will call the project basic language, create it in the folder where I have already cloned the repository to. Of course, you can select whatever your location you would like to have here. And then MPS asks us for the name of the language that we would like to create. And in this case, I will also just call it basic minus language, which obviously is not which apparently is not a valid Java namespace. So your languages need to have a valid Java identifiers as a name. So in this case, we call it basic.language. Then MPS asks us where it should put it. We will leave this on default. And then there are two more checkboxes that you can set. So one is creating a runtime solution, which would contain code that you need at runtime of your language. Currently, we do not yet need this. We can still create something like that later. But what we would like to have is a sandbox solution. So a sandbox solution is basically a playground, which MPS automatically can create for you. So the sandbox then uses your newly created language, and you can basically use it to play around with the language that you have defined. So let's check that. Project format, you definitely want to select the directory-based format here. There's also the deprecated file-based one, but this should be just leave it on default. Okay, so let's press OK. MPS will create the project for us. It's already done, so here's the project, which is not yet. Yes, okay, so now it's done. So what you can see is it has asked me if I want to add the source code to Git. I said yes, because I want to check this in later. You can also just add the files at any point in time to Git if you like. There's a full Git integration within MPS. Yeah. And then if we take a look at what MPS created, it's a solution which is named after our language.sandbox and our language with the name that we have specified. And the language is empty. So as I showed last time, MPS creates like a set of default aspects of the language when you create it. And also in this case, MPS has done that for us. Today we will mostly focus on the structure of the language, where we define the concepts that we would like to use. And we will also do a bit of editor, not too much, just that we have some kind of editor for our concepts that don't look too bad, but we won't really care much about usability there today. Okay, and then there's the sandbox solution, and inside of the sandbox, MPS has created a single model. If we take a look at its properties, we can see under used languages that it has already included our language here, so we can, this is the place where we can directly try out our language later on, once we have some concepts here. Okay, so let's go back to our sketch. Here. So the first thing that we would need here is the worksheet, which is the container for everything. So this is also like the thing that MPS calls the root concepts. So it's the container for other concept instances. So what we need to do here is, in the structure aspect of our language, we want to create a new concept. And then name it workbook. Like this. And what we already notice here is that MPS gives us an info message that we have currently no editor for this concept, and that it will use the default editor, which for now is completely fine. What we need to set is that instances can be root, because this is our starting point of the program that the user will write. So in this case, we set this to true, because the workbook itself is not contained in any other concept or node in the program. Okay, so if we build this, and then take a look at our sandbox, we should already be able to use the workbook and instantiate it in our sandbox model here. Go up to the sandbox, and we right click, we can see that now the workbook is here showing up in the new menu automatically. So if we click that, we get an editor that currently only shows workbook, because we have not defined anything else yet on the workbook concept. Okay, so as I mentioned earlier, these variable declarations that you see here, these empty lines and the print, we call this statements. So in order to be able to include different kinds of content in our workbook, we need to have some abstract base concept or interface, what we can use to indicate that something is a statement and that it's valid at this location in the program or in the model. So how do we do this? So let's first do the naive approach and just go with the first thing that we find here. So this is a variable declaration, right? So let's just or a variable in this case. So let's just call it variable. So we have a new concept variable and it needs a name, right? So if we take a look here again, we can see that there's a name required here for the variable. To do that, we can either just go here, define a property name of type string like this, and our variable would have a name. But MPS has a special kind of interface for these type of concepts. You get some stuff for free with that. Most notably that MPS will automatically show the name in various locations, then automatically show the name that you have given to this particular instance of the concept rather than just showing the alias. And that concept is called iNamedConcept, and it's directly baked into MPS. So it's also built with MPS, since MPS is bootstrapped. So if we go to the declaration, which you can either do by pressing Control or Command and clicking on the interface declaration, interface reference here, like this, or you can always press Control B or Command B, depending if you're on a Mac or on Windows, and follow a reference to its target. And in this case, what we can see is that there is a interface defined here in the normal structure definition language of MPS, and it carries a property name. We can just use that here. So when we do that, we automatically inherit the properties that are defined here. We would also inherit the children and the references. So just like in object-oriented languages, we get all the attributes that are defined on the superclass or on the interface that we have. Okay, so now we can go back to our workbook. And now what we would like to have is variables in there, right? So let's just go here and create a new child. I will call it content. And then select the variable here as the concept type for this child. And then we can also make this a list with a potentially, which is not constrained in any of its size, like this. If we now rebuild our language, we then go back to our workbook, we can see that MPS is still using the default editor, but now it also contains the content here. It's empty at the moment, so what happens if we press enter here? Then it creates a new variable and lets us specify the name, so A, like this. But now the only thing we could put into a workbook is a variable, right? So if we press enter here in the contents, we get another variable, B. We can also do C, whatever. But the only thing we could put into it at the moment is a variable. But we would like to be able to put other stuff in there as well. So what we need is some kind of base concept or interface to indicate that this particular concept or instances of this particular concept can be put into a workbook. And as I mentioned earlier, this is the type of concept here. We would call it statement. There are now two choices how we can do this. So the most obvious one, I guess, is we would create a concept called statement, and then we can also make this abstract, because we don't actually want to have instances of this floating around, because it's more or less a marker to indicate that something is content of a workbook. And then we can go to our variable and have it extend statement. And then we can go to our workbook and go to the content role here and select statement. This is one way of doing it, so using an abstract base concept. The other way, let's just build this. Take a look at the workbook. So now if we press enter, we now get some red underline thing here, which is, if we take a look at the inspector, is a statement, which is not allowed here because it's abstract. So MPS complains about that. If we now press Ctrl space here, we can see that MPS pops up the normal code completion menu, and the code completion menu right now contains the variable as a concept that we could instantiate at this location. Because we have no other sub-concepts of statement, this is the only choice we currently have. We will add more of them later, or in a minute actually. So what else could we do? So instead of using the statement as an abstract concept, the other thing we could do is using an interface for that. And this mostly depends, in this case, on your kind of taste, how you would like to design your meta model of the language. The interface gives you a bit more flexibility, so you do not imply a direct inheritance hierarchy with it. So it allows you to add the indicator that something is valid in a workbook at an arbitrary location of an inheritance hierarchy, for instance. So you can just use it, introduce it without caring about the base concept, about your extends hierarchy. It gives you a bit more flexibility. The statement base concept and then extending from there might be a bit more obvious if you are coming from an object-oriented world. So you would always allow you to basically go here and show the hierarchy of this concept. So if you press Ctrl H on a concept, it shows you the hierarchy. But this would also work with MPS's interfaces. So if you select an interface, we can do this on einem concept, for instance, here, press Ctrl H, and then see the complete hierarchy of all the concepts that implement this interface. For our example, I will leave it as an abstract base concept, but you are mostly free to choose. There are some cases where you definitely want to use an interface because it gives you more flexibility. And given the fact that MPS allows you to ship default implementations for the behavior methods that you define on an interface, it gives you this similar flexibility than using the abstract base concept. Okay, so let's take a look at the sketch again. So the next thing we see here, for now I will leave out the initializer at this place. So what we now see here is that that we need something for empty lines, right? So this is a different kind of thing that can occur at the same location where a variable can occur. So this is then also a statement. So let's create one. A new concept here. And since it's empty, I will call it empty statement. And it's also extending statement. Like this. If we now rebuild the language. And we go back to our workbook. And we go to the, actually delete this, go to the contents and press enter. We still get this, the error message that here's an abstract concept. But if we press Ctrl space now, we get two entries in the code completion menu. One for the empty statement and one for the variable that we had before. So if we select the empty statement, MPS still chooses the default editor, which in this case shows the name of the concept. But we can now put two different kind of concepts into this contents role of the workbook. One is the variable, and the other one is the empty statement. And I think now we could introduce, at least for the empty statement, a very simple editor that removes this greenish kind of default thing which only shows the name of the concept. So we can go to the concept declaration, which I do by pressing Command Shift and S, or Control Shift and S on a Windows machine, but you can also just navigate there on the left side in the structure here. So what we want to do is we want to add another editor. So let's create a new editor. So doing that by going to the editor tab here and then click to create new aspect. So we want to create a concept editor here. So let's create that one. And what we want to do here is, for an empty statement, we essentially want to show nothing, right? So just a space, or, well, nothing, at least not the default editor. So MPS calls this constant cells, and if you press Control Space at the location where you have not entered anything, what you can see here is the first entry in the code completion menu, which is called Make Constant. And if you select that, you can see that MPS has created this constant cell, editor cell, which is empty. In this case, it has this light gray background to indicate that it's a constant, but it has no content. So if we start typing here, we could also give it some string, right? Some value here. And then MPS would show that, but we want MPS to show nothing. So what we do is we create this empty constant cell here. And now we could rebuild our language like this. And if we now go back to the workbook, what you can see, there are still the three variables here, but now the green empty statement that we have seen before is now gone. But if we take a close look at the inspector at the right, we can still see that this is an instance of an empty statement. And if we press Enter and open the code completion menu, we still get the two entries for the things that we have created so far. And if we select empty statement, you can see that it's also working there. So we have now nothing shown for the empty statement. So what can we do about the variable? Let's make this also a bit more pretty with a simple editor. So let's go to the variable concept here. And in a similar way as we did for the empty statement, we create a new editor by going to the editor tab down here and then creating a new aspect. And we also want to create a concept editor as well. So MPS shows the same kind of definition language as for the empty statement, but now we would like to give it a bit more content. So if we take a look at the sketch, what we can see is that there is the keyword var in front of the name, and then there's an equal sign, and then there's the actual initializer. So let's start by adding var here. And now we would like to show the name, but there's nothing we can do actually. So if we press Control Space, if we press Enter at this location, nothing really happens. And this is because MPS assumes that all editors start from a root cell, and this needs to be a single cell. So what do we do about this? So the thing we can do is we can wrap this in a collection. So MPS calls this collections. We want to have it in a horizontal collection because we want to show var and the name on the same line. So first thing we can do now is we can type var again. MPS will automatically make this a constant. And then press Enter. And if we press Enter, at the point where we press Enter, MPS creates a new cell here in this case. Or lets us create a new cell. At this point, it's still abstract. So let's press Control Space here and see what's in the code completion menu. The code completion menu here shows as first make constant, then as model attributes, which is something annotations. We will cover that later. And then it shows some of the properties. And in this case, we want to show the name. So let's select the name here. Like this. And now let's build this again. Okay. So building has finished. And now let's go back to our workbook here. So what we can see is that it is now no longer looking that ugly. So we don't have the greenish kind of thing in front of the name. We now have var here as we defined it in the editor. The workbook still looks ugly because we have not defined any editor for it yet. We will do that in a minute. So let's go down here again. Can select the variable from the code completion menu. And then MPS automatically shows us the editor and we have to give it a name. Let's remove this for now and make the workbook a bit more pretty. So first thing that we notice I notice as a difference is that here on the workbook in my sketch, I would like to have it a name. I like to give it a name. But currently our workbook has no name, right? It only has content on here. There's nothing else defined for the name. So similar to the variable, we can use the inamed concept here and have it implement this interface. So now we have this the workbook concept automatically has a name. And let's define a very simple editor for this. So create a concept editor. And now what we would like to do is in the workbook, things should be shown not on a single line, but each element that we have, like the name here with its description, is on a single line. And I have made a horizontal line here. We can leave that out for now, I guess. And add this later. But each variable is on a single line. Each empty statement here is on a single line. So this is what MPS calls a vertical collection. So we want to vertically align all the cells of an editor. So let's select vertical collection here from the code completion menu. And now if I create new editor cells here by pressing enter, you can see that they are each of these cells is on a separate line. Okay, so let's go to the first one. And in the first one, we want to have two things. So the first thing is a static text here called workbook. And then the second thing is the actual name that the user defines for the workbook. So what we need to do is, if I would create this as individual cells here, just as it's right now in the vertical cell collection, then what would happen is that I will add the workbook here. Workbook. And then now I would like to create a new cell, right? So I press enter, and what happens is that MPS puts it on a new line. So let's select name here as well and rebuild this. So it's not only in the definition where it looks like this, but also take a look at the workbook here and see that now this is on two separate lines. And now also our content is gone because there is no editor definition that tells MPS to show the content of the workbook at the moment. Okay, so let's go back to our editor. What can we do about this? So first, let me remove the name down here. And then we have the workbook text here, and we would like to have a second editor cell that shows the name on the same line. So how can we do this? As we did with the variable, we can basically use a horizontal collection. And MPS allows you to use the intention menu for adding that. So if you are on an editor cell, you can open the intention menu by pressing Alt-Enter. And then you get various kinds of things that you can select here. And what we would like to do is we would like to add the horizontal collection. So MPS now wraps the workbook static text, the constant, in the horizontal collection. So if I now press enter, the next editor cell is added on the same line. So now let's select the name here and then rebuild and go back to our workbook that we have defined. So now you can see that this is on the same line, but the content is still missing, right? So I can give this a name as expected, but we can't edit the content. We cannot add any variables. We can't add any empty statement. So we need to bring back this. So how is this done? Let's first open the completion menu here. So MPS allows us to select the content from it here as well. So when we are on a new line here, we can open the code completion menu, and then we can see that it automatically, at the very top, it presents us the choice to select the content. So let's do this. What happened now is that MPS automatically added to the editor definition that we would like to show all of the content of the workbook at this particular location in the editor. And by default, MPS chooses a vertical collection for this. There are some cases where it infers something different, like indent layout and stuff like that. But for now, by default, MPS will use the vertical layout here. So let's rebuild this. So that already means that each of the entries in this content list will be presented on a separate line. So let's go back here. And this is how it looks now. So we now have the static text workbook. Then we have the name of the workbook. And then we have our entries in the content menu. So if we press enter here, we can create new content. When we open the code completion menu, we can see that our two different kinds of content show up there. So the empty statement and the variable. So what happens if we want to add like an empty line to the editor to separate this a bit? So just like before, we can just press enter and create a constant cell that is empty, like this. So just at the end of the collection that wraps our static workbook text and the name, the presenter, and this will automatically create a constant cell that has no content here in this case. And if we take a look at now the real editor here of the concept, we can see that there's now an empty line here which you cannot edit things on. So if I place the cursor here and type something, nothing happens. If I press backspace, also nothing happens. So this is due to the fact that we have defined this constant cell here as a separator between the content and some sort of header. Later we will add a real horizontal line here so that it's a bit more clear that this is meant as a line, but in this case I'm just trying to separate this a bit more visually. Okay, so we have two kinds of content we can put in a workbook now, a variable and an empty statement. And our variables can have names here. So when we create a new variable and select it from the code completion menu, we have to give it some name. Right now, there's also no validation, so we can give this whatever name we imagine. Spaces, also all kinds of other characters that might not be valid as an identifier in your language, but this is nothing we worry about today. So in a later episode, we will take a look at how we can make sure that nobody is using names for variables that we do not want to have. Okay, so let's get back to the sketch. apart from the name, our variables also need the initializer here. So let's add that as well. As I mentioned before, yeah, let's just give this a value here. So one thing we can do is we can go to our variable, which is currently only implementing the iname concept and extending the statement so it's applicable in the workbook. One naive approach is we might just add a property value and give it a string value, right? Like this. And then we also need to show it in the editor, which I did not do yet. So if we take a look here, the value doesn't show up. So let's go back to the variable here and to the editor. So we would like to show it like var name, then an equal sign, and then the value. So if we go do it like this, the editor is now presenting us the value as well. Yeah. So we have not defined any value for our property for our variables yet. So let's just go here and define something like this. But we could now also write something like this. But now this is only text, right? So we can't really make sense of the fact that there's 5 plus 234 in this case. What from a program, from a perspective of when we look at the model or the underlying AST of the program, we would only know that there's a variable declaration. This variable has a name and it has some value. But that this value has a certain meaning, we don't really know. The only thing we know is it's some kind of string and it doesn't carry any semantics at this point. So let's give this at least a more concrete concept, right? So static values like this in programming languages are usually called literals. So let's create a number literal to represent the these two numbers here, so that we have a 5 and a 10. Add a new concept. Let's call it number literal. And what we need to have, what it needs is it needs a value, right? So we need to store the fact that this number literal has some value somewhere in the model. So let's do this here. And now let's go back to our variable and remove the string property here. Okay. So MPS calls this children. So in this case, we would like to create a new child here. Let's call it value. And we have our number literal here. So let's just add one number literal. In this case, it's still optional. So this is 0 to 1. That means you can either have a number literal or not here. So let's do this and make it not optional. So every variable that you define in the program now needs to have a value. And for now, this value is a number literal. If we build this now and go back to our workbook, we can see that all of our property, or all of our variables that we already have defined are now broken. So let's delete all the existing things and define a new one. It still shows the editor for value here because we forgot to change it. So let's go back to the variable here. So MPS has now noticed that the property value does no longer exist here. So we also need to change the representation on the screen for it. So let's remove it and go back to the code completion menu. Before, this was a simple string property which could only store string values, and now we want to make it we want to show it a child of the current variable. So we need to change how the editor is defined here. So in this case, we would like to show the value. It has the same name as before, but now it's a different kind of relationship between the two concepts. So before it was simply a value directly stored on a variable, and now we say, okay, there is some other element below the variable in the tree that stores the actual value. Let's make the language here. Back to the workbook. And now how the variable now looks like is that we still have no name. So let's give it some, in this case A. And it shows the default editor for the number literal, because there is no editor yet, but we could give it a value here. So like 5, for instance. But let's change the editor quickly so it does not look that ugly. Let's go to our number literal, change the editor, this, and what we would like to do is we would like to show the value itself. So the number literal has no other visuals that it shows in the editor. It only shows the actual value. So let's rebuild the language here. And now go back to our workbook. It now looks like this. So we have a variable, and the variable now has a name and a value. And we create a new one. This B, we can now also give it some value here. But our values aren't always just numbers, right? So if we take a look at the sketch here, we also have like more complex initializers for a variable. In this case, for instance, a plus b, but it could also be 5 plus 10 or something. So just assuming that all variables are initialized with a single number literal is not what we want in the end. So in the end, we want to have more flexibility here. We want to have a more complex initializer for a variable. It can either be a plus here, which references other variables, or it could also just be 5 plus 10, or this is like a Boolean expression where it compares that C is equal to 15, for instance. And to do this, we need some more abstract concept in our language definition that represents all these different kinds of expressions that can be used to initialize a variable. So this concept is, we can name it expression, because this will be the base concept for everything that is used in an expression context here. So either plus expressions, for instance, or the equals expression here. We can also think about things like the exclamation mark that negates a Boolean value, for instance, and things like that. But all of these kind of concepts are some more specific kind of expression. So the abstract base thing for this is called expression. And the concept it doesn't extend anything. It also has no interfaces at the moment that it implements. There's nothing really we put onto the expression itself, because this is more or less a marker or an indicator that in our program where we expect some sort of expression, these things can be entered. So let's make this abstract, because the expression concept itself is not something we would really like to see in the programs. It's the base thing we use to indicate that expressions can be used here. So we have the expression now as the base for all of our further things that we want to put in the initializer of a variable. And now we can go to our variable here and change the concept of the value. So currently this concept is a number literal, but we want to have it more abstract. So we select the expression here. And now we can go to our number literal and make the number literal also an expression so that it's valid at that location. Expression. Now rebuild the language. Okay. And go back to the workbook. Let's delete all the variables here. Open the code completion menu again. And also throw away this. So now the content here is empty of the workbook. And we can press Ctrl space, open the code completion menu, select our variable here. Give it a name A. And now the right side of where the initializer is expected currently has no value. So if we just start typing strings here, nothing happens. So whatever we type, even if it's like valid numbers, MPS is still telling us that this is not valid at that location. So what we need to do is we need to open the code completion menu at this point. How to make this more usable and directly allow the user to enter numbers even when using the expression as the abstract base concept. We will take a look at that tomorrow because it involves a bit more things we need to do in the editor to make sure that this is much more usable than it's at the moment. But for now, we just manually open the code completion menu and select the number literal here. So now we can enter the value, in this case 5 for instance. So if we create another variable, e, and then want to give it a value, we still first have to open code completion, select our number literal, and then enter the actual value of the number literal that we would like to have. Okay, so now we have one very basic expression, but we also want to have more ways of expressing the initializer. So the next thing we see in the example here is that we want to be able to enter a plus. So let's create a plus expression. So let's create a new concept, plus expression, and it's also an expression. And now, if we take a look at the plus, we can see that it has a left side and a right side. So the concept itself for the plus expression also needs to have the left and right side. So let's create one child left, which is also an expression. It is also always required. And we have a right side, which in this case is also an expression. And it's also always required. Okay. So let's define an editor for this concept. Concept editor. So what we want to do is we want to show in a single line these the plus expressions. So the first thing we do is we select the horizontal collection because we want to have multiple editor cells that are aligned on the same visual line in the editor. And then the first thing we want to show is the left side. And then the second thing we want to show is a plus. So we just add a constant cell with the value plus. And then we want to show the right side like this. So the editor now looks like show the left side, show a plus sign, and then show the right side. Let's build this. Okay. And let's take a look at the workbook now. So let's create a new variable, C. And now we don't want to use a number literal. So if we open the code completion menu, we can see that there is no two entries because there's two concrete expressions that we are allowed to put into the into here at this location, which is either the number literal or the plus. So if I select the plus here, what happens is that the plus shows up on the screen and we have to enter the left and the right side. So on the left side, I would like to have a number as well, so 5. And on the right side, I would like to have a second number, 10, like this. But since we are using an expression for both sides of this plus, we can also nest them. So if we select the plus in the code completion menu here, it's now 5 plus 10. So we have to make this a number literal, 10, and then go to the right side of it, select also a number literal, make it another 5, like this. So this would allow us to write arbitrary expressions as an initializer for the variable in this case. Okay. So next thing we could take a look at is what kind of other expressions we would like to allow. So from the example here, we also have an equals, but if we can do plus, it might also make sense to do minus divisions and multiplications. So let's add these concepts as well. So first go to the structure here. Let's add a minus expression. And then select that this is an expression as well. Give it a child left expression. It's not optional. Right expression. Also not optional. And then we create a multiplication expression. This and select it. This is an expression as well. And how does a multiplication look like? It has a left side and right side, so we have to give it left child. It's not optional, and a right child. It's not. It's also an expression, not optional. Okay, so then we also need to define the editors for them. So we now have only defined the new two expressions, minus and multiplication. So how do the editors for these concepts look like? Similar than for the plus actually. So it's a horizontal collection where the left side is on the left. Then in this case, the minus is in the center. And then on the right side is the right. And now for the multiplication. It's a horizontal collection with the left side, the actual symbol for this expression, in this case multiplication, and then the right side. So looks pretty similar, pretty similar for all of these three different kinds of expressions, right? So this is why they are. So this kind of expression that has a left side and a right side is normally called binary expression. So if we take a look at the structure of those three expressions, I would just put the multiplication to the left here, split vertically. So we have the multiplication here, and we have the minus here. So we take a look at the structure, they are essentially the same, except for the name of the concept itself. They are literally the same. So what can we do about this? So let's create a base concept that is used to represent an expression that has a left side and a right side, which allows us to remove this duplication in this case. So let's add a new concept, binary expression. It's an expression, and it has two children, left, which is an expression, this, and right, which expression is not optional. Yes. And we can also make this abstract. This. So now we have our abstract base concept for all of the expressions that have a left side and a right side. And now we can change the implementation and replace the duplication in these different kinds of expressions. So start with the plus. A binary expression. And now what MPS tells us is that it has detected that the binary expression already defines two children with these same names, so with a left and a right. So we can get rid of them here because we now get them from the binary expression automatically to inheritance. And then we can go to our minus expression, make this a binary expression as well, and MPS automatically detects that we are duplicating things, and the multiplication is the same. Okay. So now we have removed that duplication, that we do not define the same structure over and over again in two different in different places. So what can we do about the editor? So now all of our editors are broken because we moved the left and right declarations from the concrete multiplication, minus, or plus expressions. So take a look at the editor here. It's also red because MPS has detected that these left and right definitions do no longer exist on these particular concepts. We can fix that by pressing F5, which in MPS triggers something called rebind. So MPS does not store these things as text, but it's real references to the declaration. So in the underlying program that is stored or model, this is a real reference to the left and the right declaration, which is also the thing that we see when we follow the reference here. So when we move these things around, MPS detects that the original target no longer exists. And with F5, we can basically tell MPS, okay, you know that there is something that is called left or right, but you don't know where it's pointing to at the moment. So please use this name to look for the left and right that is still visible. And in this case, it's the left and right that we got through inheritance from the binary expression. Okay. So we could now do this, fix this at all of our three editors, right? So we have our minus editor, which is already fixed. We have the multiplication that we also just fixed. And we have the plus, which is still broken. I mean, by pressing F5, we can fix that, but we still have a lot of duplication. So all the editors look essentially the same. The only difference is that in the middle of the editor, we would like to show a different symbol. So how about we try to generalize this as well? But let's first check if everything is still working. so let's go to our workbook here. And try to enter an expression again here. So if we now want to initialize our variable c, the code completion menu shows us different things. So it's the number literal, which we defined at the very beginning. And then there is the new expressions that we have defined. So the minus, the multiplication, and the plus, we can still select them and then construct our initializer 1 plus 1 here in this case. But we still have a lot of this duplication in the editor definition here for the plus, the minus, etc. So they all look the same. So what can we do about this? One way is we could use the behavior of the concepts here. So we can go to, for instance, to the binary expression, which is the abstract base concept, and go to the behavior and say, okay, we would like to create a behavior for this, for the binary expression, and then we would like to define a method that would return the symbol that is shown in the editor. This is one way of doing it. So we could define something like string symbol and then make it abstract. And then all of the binary expressions are required to implement this, this method. MPS behavior also supports adding static methods here, because this is now a method on an instance of a binary expression. But when we are in the code completion menu here, or in the editor here, what we can do is now we can define this this virtual method here. And now if we go to our plus expression, for instance, and we create a behavior here as well, we can now see that MPS tells us that we have not implemented the symbol method correctly here. So we do not implement all of the abstract methods that are defined on the binary expression. So let's implement that here. Symbol, and in this case, we return a plus. And the same is now required to do this for all of the other expressions as well. So let's do this. So the minus, create a new behavior. And you can always use Control-I or Command-I to implement, to tell MPS to implement the missing methods. In this case, it's minus as a symbol that we want to return, so the string is always minus. And for multiplication, also do that. Okay. This. And if we now go to our binary expression, we can define an editor for this. So MPS also allows us to define editors for abstract concepts. And then these editors are inherited to the concrete concepts that extend the binary expression. So in the same way as we define an editor for our number literal or for the plus expression, etc. before, we can define a concept editor. It should have a horizontal collection, and then show on the left side, first show the left side of that expression. Then what we would like to do is we would like to show the symbol, which I will leave empty for now. And then we would like to show the right side. Okay. So now this part in the middle is something that we need to do dynamically. So the content here is not static or constant as it's in the other editor definitions here. For the multiplication, for instance, this is always the constant that shows the multiplication symbol here. But for the binary expression, it actually depends on the concrete concept that we are using here, because we want to avoid the duplication of defining the same editor that has only a slight variation in showing the symbol at multiple points. We would like to show the symbol here, and to express that we want to have some kind of query function to get the value that is shown here in the editor. What we can do is we can use this thing called read-only model access, and then go down here to the inspector, and then the inspector allows us to define a function that is executed to retrieve the value for this editor cell, and the editor the value needs to be a string in this case. What we could do is we can say the value of this editor cell is node.symbol, for instance. So now when the editor is rendered, MPS asks the concrete node in this so the concrete implementation of the binary expression for the symbol that is required to show here, or that it wants to show in this location. So if we now build our, so now we have the more generic editor definition on the binary expression. And now I think we can get rid of our actual editors in the multiplication, minus, and plus expression. So I will just delete them. This, and then rebuild our language. Okay. And then go back to our workbook. And as you can see, it still works. So our minus still shows a minus. If we select the plus, it shows a plus. And if we select the multiplication, it shows the multiplication symbol. So that would be one way of making this behavior more dynamic. But what we would like to do normally is that also in the code completion menu here, we would like to show the symbol, because this is also what the code completion menu matches against, right? So if you want to enter a plus, you would actually like to type plus here and then maybe invoke the code completion menu, but the entry here shouldn't have the name, shouldn't match for the text plus expression or mul expression or minus expression. It should actually match for the symbol. And to do that, MPS has a concept called concept aliases. So let's go to our minus expression here. And in the concept declaration, we can define an alias. And this alias is used, for instance, in the code completion menu to match against. So if we define minus symbol here on the minus expression and the plus expression and rebuild the language, and then we go back to the workbook and open the code completion menu here, what you can see is now that we have added the alias to the concept. MPS does no longer show the actual name of the concept, but shows the alias in the code completion menu. So if we now type plus here, for instance, so the only thing I did when this was empty and I pressed the plus key on my keyboard, MPS has automatically detected that I want to enter a plus expression at this location. And if I press the minus key, it has automatically detected that I want to add a minus. So what we can do now is we can also do this for the multiplication actually. So that was still missing. But it would also be nice to just reuse this symbol that is defined as the alias, which is matching in the code completion menu, also for the editor definition, right? So instead of having a method that dynamically calculates the symbol, we could just use the value that we have already defined for the alias of the corresponding expression. And this is also possible by doing something by adjusting the editor definition here. So instead of this read-only model access, which we manually implemented calling the symbol function and then getting the value from the implementations, we can also select something called alias here. So alias is an editor component that MPS ships by default. And if we select this from the code completion menu, this will always show the alias for the concept that is instantiated at this location. So for all of the binary expression subconcepts, it will show the alias that was defined for the concept here. So if we now rebuild the language, we shouldn't see any difference. Let's remove this, type minus, and it still shows the minus to us. But now we can ensure that the thing that we show in the code completion menu always matches what we show in the editor. So there's no way that the thing that is here in the code completion menu is no longer aligned with the thing that with the symbol that we show in the editor. That also means we can get rid of our abstract symbol method and delete it the various places here. So remove it from the binary expression, and now MPS also complains here that this symbol is no longer implementing the symbol is no longer overriding the symbol method by indicating with this error here. So let's remove all of them because we no longer need them. Let's rebuild the language. Yeah, and our workbook still looks the same as before. And now if we press Ctrl space here in the code completion menu, we can also see that our entries are still there. So if we select the multiplication here, we can see that MPS automatically inserts the multiplication plus and so on, and this all works. But for numbers, we still have to select the number literal first and then enter the actual value that we want to have here. So always have to go to the code completion menu, this, and then select it. Tomorrow we will take a look at how we can get rid of that as well, by making this a bit much more user friendly and make it much more feel like a text editor, because right now it still feels quite alien to somebody who is used to enter text here, and also users will expect that you can enter text at this location because it looks like plus minus things that they are used to enter in a specific way, and we should make the editor as comfortable for these users as it's possible. Okay. So right now we have the plus, the minus, the multiplication. We could now add another binary expression that is division, but I don't think that matters much. It's just more of the same, right? So we can just add additional concepts of the binary expression, but I don't think it would add much more. Okay. So one thing we are still missing is that when you press enter here, you get this red things, right? So what's what you expect when you press enter at an empty line or in the program here? I think the expectation of the user is that we automatically add an empty line to this this location here. So how can we do this? MPS allows us in the editor here to define something that is called default element factory or element factory, I think. So go back to the workbook. Let me delete everything. And now it's empty. And if we press enter, MPS now wants the user to input something. So to select what we should enter, put into this specific location. So an empty statement or a variable. But why don't we just insert an empty statement by default? So by just pressing enter here, we don't put the model into a state where it's in an error state, because MPS has automatically tried to instantiate a statement which is abstract. So how can we do this? It's also part of the editor definition. So if we go to the editor definition of the workbook, and then we navigate to the part of the editor that is responsible for showing the content, and we go to the inspector down here, we can see that there is something called element factory down here. If we press enter on it, MPS now has allows us to write some piece of code that is used to create new elements by default. So what we would like to do here is, in that case, we would like to create a new node. And the node is of type empty statement. Like this. So what now happens is, every time the user presses enter in the contents of the workbook, we create a new empty statement. Let's try it out. Let's remove everything and make it empty, and now press enter. And now it does no longer create these red empty line things, but creates real empty. It does no longer create these abstract instances of an abstract concept, which sounds strange, but in MPS it's possible to create instances of abstract concepts, at least technically. But as you have seen before, the checker automatically instantly complains that you have instances of these abstract concepts somewhere. So now every time I press enter, there's a new empty line added here, and the program is still correct because it's no longer an instance of something that is marked as abstract. And if we go to one of these lines and press Control Space, so open the code completion menu, we can see that it still shows the empty statement here, but it lets us also select the variable. So this, we could invoke the select that we want to create a variable instead of the empty statement. It's a number value again. This, press enter, and now even if at the end of the variable declaration we press enter, we get an empty line automatically, because in the editor we defined that by default create an empty statement here. But what we can't do at the moment is type here, so there's no way of typing something. If I press any keys on my keyboard, nothing happens at this location. The only way to add a new variable in this place is by selecting it from the code completion menu. Okay. We can also remove them here and add new at various locations. So all of this seems to work as we expected. We could, let's take a look at the sketch again. So what have we built so far? We have built the possibility to define variables. They have a name, they have some initializer, and initializers can be of different kind, like simple numbers, or more complex expressions like plus, minus, multiplications. We haven't implemented the comparison here at the moment. Let's do that as well. So let's actually implement two kinds of comparisons, so that something is equal and that something is not equal. And since this, and this is a binary expression because there's a left and the right side, the thing that we want to show in the code completion menu is the two equal signs behind each other. We could also choose different notation, but I think for now this is good enough. We don't need to do anything else here. So adding a new binary expression is now pretty simple. You don't need to define any editor. The only thing you do is you create a new subconcept of the binary expression, set the alias, and everything else you get for free. And then let's also add the not equals expression. Not equal expression. Here it's also a binary expression and the symbol is exclamation mark. Let's rebuild this. Go back to the workbook. Go to one of our variable declaration here and see that in the code completion menu, the equals and the not equals show up. If we select it, we get, without writing any additional editors, without doing much work, we get all of this for free. So we have now an equals with the left and right side. So do something like 5 equals 5, like this. Okay. What we have not built yet is a way to express strings. We can add that as well. And since it's a literal in the program, we call it string literal. And it's also an expression. It has a value, which is of type string. But it also has an alias in the code completion menu. Because when we can leave that out for now. Let's just use the defaults. See what I mean. So how does a string literal look on the screen? In the sketch, we have like the delimiters on the left and the right side, and then the actual value in the middle. So let's also define the editor like this. So it's on a single line, so it's a horizontal cell collection here. And then the first thing we show is the first delimiter. Then we show the value. And at the right side, we want to show a delimiter as well, like this. Okay. So this is our very simple definition of a string literal. Let's build this and try it out in the workbook. So remove this, open the code completion menu, select string literal, and like this. But what you notice now is that we have to do delimiters, but they don't really look nice, right? There's this weird space between the actual value and the two delimiters on the left and the right side. So how can we fix this? By default, let's go to the editor definition. So we have not defined any spaces here between the actual value and the delimiters on the left and the right side. But by default, MPS puts a space around each editor cell that it encounters here. So the delimiter on the left side has a space around it on both sides, and the delimiter on the right side. But what we'd like to do is we would like to get rid of this. So we would like to have the delimiters be next to the actual value that we define. So how can we do this? MPS allows us to set this via styles. And this is something you just have to know. There's or look in the documentation. And the style is called punctuation, because it's also heavily used in cases where you would use like a dot to express a path. So you have like a complex data type and you want to do like a.b.c. This is also heavily used because between the dots and the two and A and B, you don't want to really have a space. So On the right side, we want to have the delimiter to be close to the value that is left of the right delimiter. So what we want to do is we want to indicate that punctuation should happen on the left side. So what we select from the styles menu is punctuation left, and it's automatically set to true. By default, it's anyway false if it's not defined, but yeah, there's also in cases where styles are overwritten and stuff like that, you might want to do true or want to explicitly set the value to true or false. In this case, we just leave the defaults. And we have the delimiter on the right, on the left side, and this one should be close to should have no space on the right side of it, so that it's close to the value. So what we do here is we select punctuation. Punctuation. Right. Okay. Build the editor. Yes. And go back to the workbook. And since MPS has this projectional editing behind the scenes going on, as soon as we change the editor definition, all of the existing editors automatically update, because the thing that you see on the screen is just a projection of the underlying data structure. So we just changed the editor for the string literal here, and it's automatically reflected in all existing string literals in this case. So now you can see that the two delimiters of the string literal are nicely aligned with the value in between. Okay. Go back to the actual sketch here. So what have we done so far? We have the variable declarations. All of this is done, right? We have the string literals. Now, one thing we could do today is we could add the optional types here, but I think I would leave this open for a later episode where we specifically talk about type system and the applications of the checking here. Right now, at the moment, the program isn't checked for anything, so you can write whatever type of expressions you want to. So, for instance, can do things like a variable x, and then say we would like to do a multiplication of a string literal something and a number literal 5. 4. Maybe the language allows this. In this case, it would result in, I don't know, 4 times something or things like this. But at latest, when we do something like this, like this, we really don't want to allow this, because what's the semantics of this at this point? Or if we subtract something from 3, for instance, in these cases, we want to show an error to the user because it's definitely not correct what the user has written here on the screen in their programs. So far we have some very basic concepts, but the editors are still like very, very cumbersome to use. So you have to invoke the code completion menu at various occasions to either get numbers or string literals, or to even, you can't do something like this, right? So if we have a number literal here, and then you want to now plus, currently the plus here works just that the value of our number literal is now 34 plus, etc. So there's no checking currently involved at all. It's also not possible to continue typing here. So if we want to change this to 34 plus 5, the thing we need to do is we first need to remove the 34, then select the plus, type select the number literal here, 34, then go to the right side, select the number as well, and then enter the 5. So our editors are very basic. They are not really friendly to use yet. But this is something we won't look into today. You can't type here. So if you are on an empty line, you can't change the content of it. So you can't type var and then a variable is created. Also, the code completion menu here still shows the empty statement. I don't think there's any point in selecting an empty statement from the code completion menu. Which user would go there, and if he can just press enter, open the code completion menu and manually select the empty statement here to edit, this makes little sense. So this is something we should take care of. Also that you can't enter these expressions nicely. There's also no checking going on if you combine numbers and characters for a number literal. Yeah. So that's what I wanted to do with you today. So getting to the point where we have these basic concepts, some basic expressions going on, no checking at all, but we can at least enter a program that looks similar to the thing that is in my example here. We can't define the optional types yet. We will do this later in one of the following episodes. And we don't have the print statement yet, but adding that is just more of the same kind, right? Okay, so I will commit this so that it's in Git. What you can do inside of MPS is either use the VCS menu up here and then invoke the commit action, update project, etc. How you it's basically the same as in any other JetBrains IDE. So we can commit directly from the IDE, and then MPS automatically selects what we want to commit. In this case, all the files that we have defined, and there are some. We also want to include these. So what MPS did automatically is include the project-related files. So similar to what IntelliJ stores into the .idea folder, MPS has a .idea for a .mps folder where all of the project-related files are kept. In this case, it's like migration information, VCS information, the name of the project, what's the actual content of the project, things like that. And then MPS also includes our language definition here. So in the languages basic language folder is the definition of the individual aspects of the language. So each aspect has a separate file for the behavior, the editor, and the structure. And then there's also our sandbox solution here, which MPS has put right next to our language definition, and it only contains a single file in this case. So let's commit this. So add initial version of expressions variables, and let's start at the very beginning. So add initial version of workbook, variables, and various expressions. Like this. MPS allows you to perform all different kinds of analysis before committing, like checking if there are any problems with the models. This is here, and then so perform check on affected models basically means check if there are any inconsistencies in your code. So we can just click commit here, then MPS will involve the okay. I haven't set the Git credentials actually. No. Wait. Let's check something. Okay, I have not set it. So let's do that. Set the credentials as well. Git config. Minus set minus global, I guess. Yeah. In MPS it's quicker. Let's commit here, and now MPS asks us for the show credentials. So let's do. Okay, set properties globally, set and commit. Okay, so now if we take a look at the VCS history, can I see that somewhere here? Git show. Nope. Why is it not? Here. Okay. Okay. For some reason, MPS has decided to not show the. Maybe I've never activated the tool window. Yeah, version control. So now we can also see that the that in the Git history the things have been committed, and MPS also allows us to diff these things. So even though if we take a look at the files on the file system, let's do that for a second and just show how the Git integration with MPS works. So if I just show the content of one of these .mps files, you can see that this is the serialized form of the program. It's not text. It's in XML encoded version of the underlying abstract syntax tree of our program. There's some more information in here, like which concepts are used. So there's a specific storage format that MPS is using, but behind the scenes, this is XML. And when you do diffs on this with a normal text editor, you would just see diffs in the XML, which is quite not really readable at all, not even for simple programs. So as you can see, there's we can see some of the values that we have put in, like hello world here, or the names of the variable or stuff like this. But even the properties are not encoded as the names are not encoded here directly. So you really don't want to do this on the console. But what MPS allows us to do is to diff this within MPS. So if I open this commit and I select the behavior here, then MPS shows this with the editor that we have, that MPS would also show to you for defining this. So let's go to our basic model here. What we can see here is we have added the my workbook, and that the my workbook looks like this. So MPS behind the scenes will read the XML and then present you a diff on the actual DSL. And this also works for your custom DSLs. So for free, you get the diff view for the concepts that you have defined. So in this case, we have added new things here all over the place. So let's remove something like this, the variable b. Let's remove it and commit this as well. Remove from the sandbox workbook, committed. And now if we take a look at the commit in the Git history here, you can see that we changed the sandbox here. And if we double click on it, MPS presents us a diff, and we can see that we have changed something in the my workbook. And in this case, we removed B here. So MPS indicates this with this gray line, in this case in the diff, so that the content was removed at the new vision here. So we haven't defined anything how MPS should show the diffs for our language. You get this for free by the MPS runtime. It will look at you. It will load your editors and then present you a diff with your notation of your language. Okay, so I will push this to GitHub now. Oh, I can't. I think I don't have credentials in this. Okay, I will push this to GitHub later, directly after the stream. And that's it for today. So I hoped you got some useful information. We will continue tomorrow with making the editor much better, much more user-friendly, and feel more like a text editor. We will do this first manually by using the normal MPS built-in mechanics to do so. And then we will take a look at something called grammar cells, which is an extension to MPS, which should greatly simplify these definitions of the editors and help us to build more consistent and better editors with less effort. Okay, so that's it for today. Hopefully see you tomorrow. And if you have any feedback, you can either leave it to me on Twitter or on Slack in the MPS Slack. And there's a dedicated room for the streams that we do here. And just leave your feedback here there. I'm most of the time there as well. So if you want to talk, give ideas, etc., do that there. And you can also find the code from today after I've pushed it on GitHub in this repository. And if you have ideas there or you want to implement something and we should have a look at it together, send a pull request, open issues for ideas that you have, implement something if you like, and we can take a look at that as well. Yeah, so your feedback is always highly welcome. And that's it for today. Bye.